Hi, welcome to Kinetics KL25 ARM Cortex M0 Plus based bare metal firmware programming embedded system development with the Freedom KL25 platform. Basically, this course targets towards the beginners and intermediates who can get started with the embedded systems programming and get deep dive into the embedded system programmings using the ARM microcontroller. Basically, what we are using is that NXP Kinetics KL25 ARM Cortex M0 Plus microprocessor for the complete program. Here we have that the course content, we just start with that basics architecture of ARM Cortex M0 Plus and then Kinetic Scale 25 ARM microcontroller, what are the peripherals available, what are the interfaces available in the Kinetic Scale Mic 25, and then there is a SDK and IDE called MCU Expressor SDK and IDE that we will how to install and how to get started with that and how to make that development environment setup, and we shall move forward with the development platform, Freedom KL25 development platform, and the different Kinetics SDK peripheral driver APIs available for each interfaces, starting from GPU, general purpose input and output. Basically, this contains two variants of implementation using a direct register success, a direct without anything we can directly read the processor contents, data sheets, and implement the functionality, very bare metal functional implementation. And then we also have an kinetics peripheral driver APIs information and how we can implement using the peripheral driver APIs. It has something like we will start with that peripherals, general purpose input and output, and we will access the LEDs and keys basically, and then we will jump into interrupt handler and service routine, interrupt vectors, how we can configure the interrupts and how we can get the interrupts, how we can service the interrupts basically. And then we move on to the timer, the NXP's low power timer and periodic interval timer, that we make a small implementation of DHT11 temperature and humidity sensor using that the GPU concepts and the timer concepts. Integrating both, we will develop an DHT11 temperature and humidity sensor driver or application to access and get that the current room temperature and humidity basically. And we move on to that analog to digital converter, and with the analog to digital converter we will read that the potentiometer readings and get that across voltage across the manipulate the voltage across the potentiometer, and we move forward with the MQ2 gas sensor. We shall read that analog to digital conversion, and based on that we will make a live demonstration when we initiate the gas, how drastically that analog to digital conversion value goes and how we can able to make a fire alarm based on the gas sensor. Then we move to very standard interface, inter-integrated circuit interface, which is an I2C, and we will develop an bare metal firmware for MMEA8451 accelerometer and to access and to configure to get that X, Y and Z offsets using bare metal firmware and Kinetic SDK peripheral driver based APIs as well. And we have moved forward with the universal asynchronous receiver and transmitter, which is something like which is used to create an serial ports in all the platforms, and we demonstrate with the USB to UART TTL connection with the PC and make that serial port access from the Teraterm, how we will receive the data and how we can able to transmit the data back to the PC that we have the demonstration and implementation of universal asynchronous receiver and transmitter. Yeah, let's get started and deep dive into the embedded firmware in the bare metal and the kinetics SDK form as well. Thank you. We will get started